Hello and welcome to lesson 3.06, where we will be talking about land utilization and how to calculate that in LEAP. In this video, I will introduce you to land type utilization, which is a measure of how the physical land or the geographical land is measured and used in your model, how we will enable that, how we will set up our different land types, and how we can do land type change based on our consumptions in our model. So what is land type analysis for starters? Because it's not actually something we have in a lot of energy models, even though we probably should. So we define in land type analysis, we define the biomass resources instead of just having their energy or their tonnage. We can define that further as their resources by the land types and the number of hectares that it takes to yield these different biomasses. So therefore we can find the necessary yields from the different land types that will go into our biomass and our conversion to energy. Then we can also see if, based on how we utilize our land and how that changes, we can then see how our land type changes and whether or not that is sustainable on a resource basis for land types. So, and this in LEAP is something that you can enable as a user, and that's what you do specifically for your different fuels. Of course, mostly biomass is where we use this, but you have to enable that yourself. So I will show you how in this video. So enabling land type utilization is something that we do as per usual in our settings. So in this case, we have to put on the land use change and land-based resources, and then we can actually start using it right away. It's quite easy. Here we're going to look at what happens when we are adding land type analysis to our model. So you see we have quite a simple model here with a bit of demand, transformation, and resources. Now we go up into settings, we put on land use change and land-based resources, and we can now see we have another branch called land areas. Here we have land conversions, which is right now empty. We'll get back to that, and we have land types. And here we have a number of different land types. If we try to add one, we can see we can't actually do that for reasons unknown. We have to do up here in the menu called land types. So we add here. You can see we have different types of land types. The colors are in results. That's not useful right now. And we can just define that with a name. For now, we are just going to stay with this. Now, how do you actually start? How to actually use that in defining these, we'll get back to in the next video. Now that we have our different land types set up, we can now define how these land types are in our system and how much we have of them. And we will do this as so. So under the land areas and under land types, you can see we have all our different land, the different land types specified in the menu. Here you can see that the land of a region, so far we don't have regions, so we just set that as no. And other than that, we can see how much of the existing land area are of the different types, and we can set that. So in this case, we are going to set that in 1,000 hectares. And we can start setting these value in. So we'll just put here, we'll put 5,000 hectares for urban area, meaning cities. I don't think we're going to set, we might set a little bit of rural, 40,000. I think we can change that to hectares instead. So that's if 1,000 hectares might be a little bit. This is a small country, so we'll change it to that. Large farms, that will be quite a big part of our country. So we'll set that to 5 million hectares. Small farms, even bigger. That's we're because you're saying we are a developing country, we probably have mostly small farms, and we are industrializing to in the agricultural sector as well. So we'll start with 12 million small hectares with small farms, and then we have quite a lot of natural forests as well, 50 million hectares, and then we also already now have converted some to commercial forest. So we'll put that in as 50,000 hectares, 500,000 hectares, sorry. And for now, we're just going to leave most of this as a smaller areas. So now we filled in our entire land areas. We can move on to the next part. And it should be noted that this has to be done in current accounts because it is existing land area. Now that we have defined how many different land types we have in our area, now let's look at how some of these fuels might be using these land types. So away from land types, let's go down to our resources, and here we're going to take our primary resource of wood. Technically we could do all of them, but it is biomass resources that is where we're talking about now, so that's the interesting one. If you go into its properties, that might be outside your screen, but the top menu properties are all P, and you will see that this is a type biomass, and you can say disaggregated by land type. Turn that on, okay, and there you can see under the wood we have all these different land types. What we have here for these is that we have the unit yield of the different land type for creating wood. So how many in this case, gigajoules per hectare do we get from the average hectare of the different land types? So most of these are irrelevant, but let's say for natural forest, we're just going to define that in our current account, so it bleeds down all the way. We're going to put that to 0.01, and for commercial forest, that's much more effective, so we can say 0.05. Good. So now wood is dependent on our land types. Now in our land areas, we can tell how much land area we have in our beginning of our model period, and we can tell how much yield we get from the different land type for the different fuels, in this case just the wood. Now what if we change our land types, meaning land conversions? We come down here, we can, I'm just going to pull that up a little bit so it's, come here, so we can say add, and then it tells us, well, what do you want to convert from? In this case, we're going to convert from natural forest, and we're going to convert to large farms here. That is that's what happens in quite a lot of the world, especially when we have rainforests. So let's try to go that. You see here, natural forest to large farms, that we not made a land conversion, and that has to be above 1. We cannot define any of this in the current accounts because that's something that happens in the future. I'm just going to put this back to just hectare, and I already prepared a little formula. So now you can see here I'm saying that in 2010 we are converting a 25th of the original forest. That's the area here. And then in 2025 we have pushed that to a 28th, or I guess push it down a little bit. Yeah, I can do it. I can. Sometimes it's just being weird. We can define that in current account, so let's do that. Good. Still counts for in baseline. So now we're converting quite a lot of hectares, and then we're slowly adding to less, and then it stagnates. So let's try to calculate that. We'll do that next video. Now we'll calculate our new land type scenario, land type addition to our model. So we can see, oops, source land type natural forest exhausted in 2039. So we spent all of our natural forest, convert that. Land conversion cannot continue. So now it's throwing us an error saying you actually used all your forest. That's probably a pretty good idea, but I want to see what happens if we actually do that. So I'm going to go back to the settings screen so as it allows me to. And here you can say check land conversions against available land area. I'm going to take that off, close, and then try to calculate. Now it just throws a diagnostics error, so it still runs, but it just says if something is off. You can see that under diagnostics if you have any. I'm not interested in this right now. I am interested in land areas. So here we can see we have the land area. We still have the same total land area. Of course, our country is not getting smaller, but you can see that the large farm is taking quite a lot more up of the total land area. And then the natural forest, which was a big part of our country or area, is then falling down to, well, basically zero by 2037 because we exhausted all and giving that to large farmstead. Of course, we could make those more complex, so we can make some of it small farms and urban and so on, commercial forest and other things too. Now we can also see yields. So we defined how much our yield intensity really was. So yield per hectare. So let's now calculate out how much yield do we actually have all in all. So you can see we still have the same yield because we haven't converted any land into commercial forest, but our yield goes down quite a lot from just because of the conversion that we have done. So this is just linear. Of course, if you had made a smoothing or an interpolation that's more complex in the conversion, that would also look differently. Not great. And here you can see how much land is converted. It's quite a lot. We can even take that in cumulative values. We can see it's a lot and then no more. So again, that's when we have exhausted our area in about 2036. Good. Now we can then say if you have resources, we should be able to see that with something with wood. So if we go here with primary, we can see indigenous production. We're getting quite a lot of wood a lot of times. It doesn't actually affect the wood production as of now in the leaf model. So that is something to be aware of, that even though we destroyed most of our forest, that the wood is coming from and therefore destroyed our yield down to very little. It still continue to have quite a lot of production unchanged from wood. So those two are not combined as it is now. It's the same you can see here. The wood still is increasing. It's just a lot of coal in the baseline scenario. And now we just take a moment to quickly discuss the usability of this land use analysis. There are three main uses I see that can be useful for this for you as a user. The first one is if you have quite a large changes in land types. You see that quite a lot in quite a lot of countries right now, where you may go from natural forest to commercial forest, or are going from rural areas to urbanization. This will have effects on your yield for biomass and also for your general agriculture. So it is good to be able to analyze that, at least for the energy sector. The other thing is that if you have a rapidly industrialization in your agricultural sector, meaning you will go from small family farms that might be quite manual to big industrial farms, which we have seen happening in the Western world quite a lot. This will probably create a higher yield in your agriculture sector, which will then leave room for higher use of biomass resources for energy. Now the differences, the third option is the differences in energy use. quite a lot of countries at the moment are importing biomass or exporting biomass for use in their larger energy sector. This could also be a good idea to analyze the use or the resources of specific biomass resources, to analyze the need for imports or the benefits you can gain for exporting these. If you want to go to a more realistic example, I have made one here, but I have followed the same method. I just took pictures instead. So in this case, I made a few new fuels. As you can see here, I made some rice husks, vegetable waste, and straw as fuels, as primary fuels that we use. So I no longer just define biomass as just wood. We still have wood down here, so I didn't change that, but I wanted to look more into agricultural byproducts for energy. Now you can see all of these three agricultural products or agricultural fuels, I made those land type based, so they all contain this land types in our analysis. These different forms of solid biomasses or agricultural and wood waste products, I have then combined through my transformation, which I will show in a bit, to another secondary fuel called soil biomass. So that means I'm mixing the different biomass types to create the solid biomass. In this case, then that means I can define my fuels much more granularly than just having biomass as a central resource. But here we can define our agricultural byproduct or energy byproducts from agriculture, both for rice production, from wheat production, and vegetable waste for all other forms of production that might be more statistically relevant. Here I then also have added, for this example, more conversions in this case. So I have taken all my land areas, I have defined them, and then in this case I have also instead gone for several land types that I thought would be realistic for our system. So I have from natural forest to large farming, natural forest to commercial farms, commercial forests, natural forest to small farms as well. So we have all the different types of, and also natural forest to wasteland, because some of this is wasted if it's being burned, for instance, which is going on more now in the world. So we can see all the things that impact natural forest. And then we also are looking at urbanization. So we are saying that comes from large farms specifically, and commercial forests that are near cities are then being converted to urban areas. So that's what we see here. We're converting quite a lot of natural forest, but also a bit of the large farming and commercial forest. If you look closer a little bit to that, which is interesting, that is, we are both creating large farms and we are also removing large farms at the same time, which is also fully realistic in a real system. That some places we make room for new farming, but other places they make room for something else. So in this case, as I said, we have made 3 new fuels: rice husk, vegetable waste, and straw. And we want to make that into solid biomass. And we do that just in the transformation sector, more or less anywhere we want. In this case, I just put in a mixing process with next to no losses. And here I'm saying that we are quite dependent on straw. We are producing quite a lot of straw. So we have 50% straw, 10% vegetable waste, and then the remainder, which means 40% of that being rice husk. So a bit of a mixed agricultural sector. And all of these I make into solid biomass. Then I use that in my demand sector. And here we take a close look at that, just to show that it's very. I made a new folder just called Biomass Mixing. We can also do this to make biofuels. It's a similar process. And then I just made an output. I made a new output fuel called solid biomass, and with the input fuels as my our feeder fuels as the ones that I defined as primary fuels. Let's look at some results. So in this case, you can see that we are converting. This is a land area conversion. So through the years, we start off by converting a massive amount of natural forest, and we will continue to do so in our system, though to a lesser degree. And we are also converting more so large farms that doubles throughout our timeline, and then we can see we are actually running out of commercial forest quite quickly already in 2035 because we have overused those. So that's a clear result you can get that this is probably not a sustainable method of doing anything. If you look at the next one, we're looking at our total land types that we have throughout the year. So here we are seeing not the greatest results, I guess, but this is the natural forest, how we have a massive decline in that to about half throughout our timeline. That this is probably a measure of that this is not sustainable, that we have too much yield, too much conversion. We can see the yellow here being commercial forest, which was quite small, that completely disappears. Because it's being converted to urban areas. We can see how our urban areas grow from very little to quite a lot, while our small farms stay more or less the same, and our large farms grow to quite a lot of bigger. So we have an agricultural expansion in the area on behest of the natural forest, which is a good thing to analyze when we're doing our different scenarios. So if in a very biomass-centric scenario, this could be the consequence without us realizing, without using these analyses. So that's what they're good to do.